Let's consider the context of this question. This question is about a continuous water wave. On this continuous water wave, there are 2 points x and y, where they have a phase difference of 3/2 pi radians. We are also told that the waves are traveling from point x to point y. The question wants us to consider what is the displacement of a dot at x and the movement of a dot at x at an instant when the rubber duck at y is displayed downwards and the rubber duck is moving downwards. So the best way to tackle this question is actually to consider the displacement distance graph of the wave. The displacement distance graph gives a good representation of all the particles at that instant. So let's start by first drawing the displacement distance graph, which is basically just a continuous sine wave. The dotted line represents the equilibrium position. Let's assume that the wave is traveling to the right. Now, we want to identify a possible position for rubber duck y, given the description in the question. So we're told that the rubber duck at y at this instant has a downward displacement and is moving downwards. Hence, a possible position could be this position. This identified position is below the equilibrium position, and hence the displacement is downwards. At the same time, considering the wave moving to the right, next instant you expect this point to move down, and hence it is moving downwards at the instant. Next, our job is to identify where is a possible position for rubber duck x. The hint to us is x and y has a phase difference of 3/2 pi radians. So recalling the phase difference formula, that is phase difference over 2 pi is equals to separation over lambda. Given that phase difference is 3/2 pi, we can easily find our x. Realize that x is actually equals to 3/4 lambda. So a possible position for a rubber duck at x is 3/4 wavelengths to the left of y. And hence, we can identify that this particular position is a possible position for rubber duck at x. This identified position is above the equilibrium position, and therefore the displacement is upwards. At the same time, since the wave is traveling to the right, you expect this x position to shift down the next instant, and therefore at the instant, the motion is actually in a downwards direction. Hence, option 4 is our answer.